So where is everybody approximately in their?
I'm finished with the first week already.
I'm at 24%, which I believe is like dang, what was I was just on it. It was I don't know, I forgot. I'm sorry. I'm
You
innocent.
know, Mr. Young, you're doing all the quadratic stuff. You're not doing the radical stuff. You're not.
Is
You're supposed to be doing according to the calendar. Did you
but
not?
it won't let me bypass it.
Yes, it will. Everyone else is doing it.
Everybody else bypassed it?
Yep.
Oh my God.
Yep. So you're doing the wrong chapter. You're doing the next chapter if not having done the previous chapter.
Okay, so I'm finishing up the next chapter. I'll go back and do the last chapter.
Yeah, okay. So for some of you who did not do so well in your quizzes, I have given you extra retakes. So that's there. So you should have seen it this morning or this afternoon when you had logged in that you had extra quizzes. So today and tomorrow you should be finishing up multiplying radicals. Okay. So by the end of this week, I need all of these assignments done. So the square root function, rewriting, all this stuff. And next week will be your first test. It will be on Tuesday and Wednesday. And as I said yesterday, the way I want it done is I want you to try or attempt the test on Tuesday. And then if you don't do so well, then go back and retake it on Wednesday. Remember, you only have one retake. So if you don't do well on the first test, that means you score less than a 60. You have one more attempt to do it in. And if you don't get a higher score then, whatever grade you get sticks. So be careful on how you take the test. All right. So let's start off by doing a couple of multiplication problems. And let's go over some stuff that we did yesterday as well. Let's have you guys multiply numbers 34 and 36. 34 and 36.
36. 34 and 36.
Okay, so what do we do first? Okay, next problem. So what do we do? How do we multiply these two binomial radicals? Make sure you unmute yourself to answer. Somebody, I'm waiting. What do we do first? Which ones do we multiply first? Okay, so I'm going to go ahead and go forward. So remember, we foiled these. So we multiply 6 times root 24. So 6 times root 24 is root 144. Okay, and then we multiply the outside, multiply the inside, and we multiply the last. So which ones can we take out from underneath the radical? Which ones of these can come out from underneath the radical immediately? Well, which ones of these are a perfect square?
6.
Okay, 16. And what does 16 become? What does root 16 become? Well, what does root 16 become?
4.
4, good,
And then 144 would be 12.
good. Okay, now can I separate root 12? Can I further simplify root 12? How can I break up root 12? Into which two?
4.
4 and 3. Whoever's playing Call of Duty, stop. Thank you.
No, that's actually 4, not Mr. D.
Oh, sorry, but whatever you're playing, stop it. Okay, what about root 192? How can we break up root 192?
So 20.
What two numbers multiplied to give me root 192, one of which is a perfect square? I can still hear somebody clicking away on their Xbox or PlayStation 4, so stop it.
No.
So what two numbers multiply to give me 192? 192? Well, anyone?
24 by 8.
24 and 8, but 24 and 8, neither of those are a perfect square. I need two numbers that multiply to give me 192, one of which is a perfect square. So remember your perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, and so on.
Could you do 12 times 16? Because 16 is perfect square.
Yeah, you can do 12 and 16. Good. And what does 16 become?
4.
4. Okay, so this is 4 root 12. The other 4 comes down. What does this 4 become? What is the square root of 4?
2.
2 root 3. Good. Now, can I simplify any more of these? Is there anything else underneath the square root sign that can be simplified?
The 12,
12. And how can I break up the 12?
6 and 2.
3 and 4.
3 and 4.
3 and 4 is that too.
That's the one you need. 6 and 2 would not work because neither 6 nor 2 is a perfect square. Remember, you need one factor to be a perfect square. So this becomes a 2. Now, what can I combine?
12 and 4.
Which becomes
3.
what? 12.
Oh, no, my bad. 16.
What else
And 2 and 8.
becomes?
10.
Good. Any questions? All right, so let's do the next one.
Is the FOIL method.
Okay, do the FOIL method. And what is the FOIL method?
The little faces, like you made a shape where it makes a face.
Okay, so the first, when I multiply the first terms, what do I get?
You get 6 square root 30.
Okay, and then I do the outsides, and what do I get?
You still get the same. No, you get negative 4 square root 20.
Okay. Inside,
9 plus 9 square root 45.
and last.
Negative 6 square root 30.
Okay, now we simplify. Which ones can we break up? Can we break up 30 into,
You can do 6 and a negative 6.
30 is 6 times negative 6?
No, not the 30. I'm saying you could
For 45, you can do 9 and 5.
Okay, so 45, you can break up 45 into 9 and 5.
And 26 and 4.
6 and 4 is 24, not 20.
Oh, my bad.
What can I break up 20 into?
4 and 5 and 4.
Okay. Now, which one of these comes out of the radical?
You mean like which one we can eliminate the opposites?
Well, no, which one can I get out from underneath the radical? Which ones of these numbers? So like, for example, in this situation right here, okay, in this expression, which one of these numbers comes out from underneath the radical? What is the square root of 4?
16.
No, square root of 4 is not 16. Square root of 4 is what?
6. I mean 2.
2. Okay, and what is the square root of 9?
3.
3. So negative 4 times 2 is negative 8, root 5. 9 times 3 is 27, root 5. 6 root 30. Now, Is there anything else that I can break up into two different products?
The
Okay. Now, can I combine any of these?
the
Yes.
6 and -6.
Okay, and what do I get when I combine these two?
-4 square root 20.
What? No.
Is that not the answer?
No. What is 6 plus -6 root 30? What's 6 root 30 plus -6 root 30?
Root 30?
No. What is 6 plus -6?
That's 0.
0. 0 root 30 or is just 0. These cancel each other out because they're opposites. Okay. Now, what about -8 root 5 plus 27 root 5? What do I get?
-19 square root 5.
Cool. Okay. Any questions about how to multiply binomial radicals? So you're just FOILing. All right. Now, we also talked yesterday about rational exponents. So how can I rewrite this using rational or fraction exponents? What is this the same as? A to the what power?
A to the 2/3 power, I think.
Right, 2/3. Okay, good. Now, we also talked about how to simplify something like this. Okay. So remember, this is m to the 11/7. Okay. And I told you to, in order to simplify, take this improper fraction. It's called an improper because the numerator is larger than the denominator. Take the improper fraction and turn it into a mixed number. Okay. Now, this is the same as m to the 1 times m to the 4/7.
So, like, would you add another 1 under that m to the 1 and multiply straight across?
No, you're not multiplying straight across. You're trying to simplify this.
Okay.
Okay. So m to the 1 is m times, remember, what does this mean? This is the denominator is the index, the numerator is the exponent. Does everyone understand how we're doing these?
Yeah.
Yes.
Okay. All right, so let's have you guys try one. Simplify. Okay, so step one, we have to rewrite this using a fraction as the exponent. So what would be the fraction exponent?
R 17 fifths, I think it's called.
Okay, good. Now we're going to break this into a mixed number. So what is 17 fifths as a mixed number? Everyone here know how to convert an improper fraction into a mixed number?
No.
No.
Okay. So when you convert into a mixed number, remember you can take the improper fraction. Remember, a fraction is a division problem. Okay. So 5 goes into 17 3 times. 17 minus 5 is 2. So that's 3 2 fifths. Okay. So this is the same as r cubed times r to the 2 fifths. R cubed comes back down. R to the 2 fifths could be rewritten using a radical sign. The denominator is the index, the number on the outside, and the numerator is the exponent. Okay, let's do another one.
You know, you could just simplify that down.
What do you mean?
Like just simplify the root, and you know, if the 4 will be gone, you get b square root b to the 5th. And once you simplify the radical, you'll factor out the perfect square, and in the radical, it would be b to the 4th times b. And the root of a product is equal to the product of the roots of each factor, being root b4 and root b. So once you factor out the root b4 and the root b, you get b2 to the 2nd and root b, and that could give you your answer right there. b2 root b.
Okay, you can do that. Yeah, that's fine. But this is the way, okay, so the problem is that there are multiple ways to do this problem, okay? That being said, I'm trying to figure out, or I'm trying to teach like the one that probably most people would try to understand. I mean, what you're doing is correct, and I'm not going to stop you from doing it as long as you get the right answer. But
Okay.
you're more than welcome. I mean, the way I'm trying to teach it is just like the one way that will, you know, most people will try to understand. So,
Okay.
so there's like multiple ways of doing it, but if you have to teach it, then this is the way they want you to teach it. So,
Is it?
okay, so step one, we rewrite this 10 to the 4, okay? And remember, how do we convert? Okay. Now here, look, it's 2 to the 4, okay? What can I can reduce this fraction 2/4, correct? What does the
Yeah.
fraction 2/4 reduce into?
1/2.
1/2. So this is b squared times the square root of b. Okay. All right. Is everyone getting it? Okay, so let's, okay, can I move on?
Yeah.
Okay, so let's do a problem like this. Solve and simplify. Solve and simplify. So in order for you to do this, you need to first remember your properties of exponents. So when you have two exponentials multiplied together, both with the same base, what are we supposed to do with the exponents?
Isn't it like you add them?
Yeah, you add the exponents, correct. Okay, so what is 2/3 plus 5/6? Please don't tell me 7/9. What is 2/3 plus 5/6?
9/6.
9/6. 9/6.
Mhm.
Remember, you have to find a common denominator. Common denominator is 6.
Yeah, but I simplify. I got 3/2.
Okay, you can do that. You can simplify it to 3/2 if you'd like. Okay. So how do I, now 3 halves, that's an improper fraction. So
From my understanding,
how is that as a mixed number?
the purchase. And so that's what I also,
1 and 1/2, good. So that's x to the 1 times x to the 1/2. That's x root x. Any questions? Right. Now, let's talk about, do I have any more problems with adding, subtracting, multiplying, all of that stuff? Any problems with rational exponents?
No, sir.
All right. And remember, how do we do how would we do a problem like number 36?
when they do that, what does that mean when they?
How would we simplify that?
Why would they make an obligation?
What would we multiply the numerator and denominator by?
The square root 3 plus square root 6.
Not square root 3 plus the square root of 6. You multiply
Or
by
minus, yeah,
minus.
minus.
And what do we call that?
Conjugates.
Conjugates. So you multiply both the numerator and denominator by their conjugate, which is 3 minus root 3 minus root 6. Okay. Now, when I multiply across, I get root 3 plus root 6 times root 3 minus root 6. Okay. Now, how do I do this other than FOIL?
Do you wait? No, that's wrong.
Remember, what is the formula? What formula do I use?
Using in parentheses a minus b parentheses another one a plus b.
So what is that formula?
Minus b2.
You do the FOIL thing, I think.
No, I mean, yes, you can FOIL this, but there's a more efficient way of doing it. So when we multiply a number by its conjugate, what is the formula?
Root.
You like square the first and then the last terms.
Yeah. So the first term squared minus the last term squared,
equals 3 minus 6.
which gives me,
3 minus 6.
which is what?
What do you mean? 3 minus? Oh, -3.
Okay. So the denominator here is -3. Okay. Now the numerator, we just multiply across, so it's 2 root 3 minus 2 root 6. Okay. Now, in order to simplify this, what do we not like leaving in the denominator other than a square root? So we don't want to keep a square root, but also what else do we not like keeping in the denominator?
Parentheses.
Well, the negative. Okay.
Yeah, that's it.
So if I give the negative to the numerator, the equation becomes negative 2 root 3 plus 2 root 6 over 3. All right. Any questions? Okay. So let's talk about exponential equations. Or not exponential equations, radical equations. And when we solve a radical equation, the first job is to isolate the radical. So you want to get on one side of your equation just the radical, or whatever's underneath the radical. And you want everything else on the opposite side of the equation, right? Then once we isolate the radical, then we're going to square both sides to get rid of the radical. Okay.
What's the D?
Yes.
Can I use the bathroom?
Yeah.
Okay.
Then we're going to solve. Then we're going to check our answers. Okay. So in this problem right here, we're going to first try to get this guy by itself. So we're going to subtract 7 from both sides. Now that the radical is by itself, now we're going to square both sides. And the reason we are going to square it is because when you square a radical, the radical sign goes away. So that just leaves me with x plus 1, or what's underneath the radical, equals 3 squared, which is 9. Now we're going to solve like we normally do by subtracting 1 from both sides. We're going to get x equals 8. Now, the unique thing when you're dealing with radicals is that you have to check to see if the answer is correct. Because sometimes you may get answers that is an answer, but it does not work for the equation. Okay. So you're going to plug it in. You're going to plug in 8 for x and see if both sides of the equation are equal. So 8 plus 1 is 9. Square root of 9 is 3. And since it works, then we say, okay, that's my solution. So these are the 4 steps. Get the radical by itself. Okay, that means get rid of whatever is being added or subtracted to the radical first. Then get rid of whatever is being multiplied to the radical next. Once the radical is by itself, you want to get rid of the radical by squaring both sides. Okay. Once you square both sides, then what you'll be left with is whatever was underneath the radical equal whatever. Then you solve. And then you check your answers. Any questions? So let's look at something like this, right? In this problem, the radical is by itself, correct?
Mm-hmm.
Okay, so the next step that what we're going to do is we're going to square. Now look, we're going to square this whole side. We're not just going to square x, we're going to square the entire right side. So the square root of x plus 2 squared is just x plus 2. Now, when you square a binomial, how do you square this? Well, so when you square something that you're multiplying it by itself. And then remember, we did this problem before in the previous chapter. We would FOIL. So we get x squared minus 8x plus 16. Okay. Is everyone following with me? What I've done so far? Have I upset anyone yet?
I have a question.
Sure.
Didn't you say before that, like, if there's a exponent on the outside, you move it to both inside?
If I have an exponent on the outside, move it to the
Can
inside?
you, like, distribute it to both?
Yeah. But
Then why would you do both?
okay, so what you're thinking about, Mr. Bordley, is this. If this was 4x squared, then yes, it would be 4 squared x squared. But this is not 4x squared. So you can distribute the exponent only when whatever is being raised to that exponent is being multiplied only. Okay? Here, I'm not multiplying, I'm subtracting. So you can't distribute the exponent when you're adding or subtracting. Does that
Okay,
make
I got
sense?
you.
All right.
Yes, sir.
All right. Now, this is a quadratic equation. How do we solve a quadratic equation? What does one side have to equal before we can solve this?
0, right?
Yeah, so remember, if I want to have one side equal 0, I got to move everything to the opposite side. I get x squared minus 9x plus 14 equals 0. Okay. Is everyone following along? Now, how do I solve this? How do I solve this quadratic? What do I have to do? Starts with an F.
Factor.
Factor, yes. So, how do I factor x squared minus 9x plus 14? What two numbers multiply?
Multiplies of 14.
Yeah. So
7
what?
and
7.
Yeah. -7 and negative, yeah.
7 and 2.
Okay. So remember, this means x minus 7 equals 0, or x minus 2 equals 0. Okay. That means x equals 7, or x equals 2. So my potential solutions are 7 and 2. But remember, this is a radical problem. Okay. This is, so you have to check every answer. So let's check 7. So we replace x with 7. Okay. So the square root of 9 is 3. 7 minus 4 is 3. So 7 works. Now, we're not done because we have 2 answer options here. So now we got to go back and check the other answer option. Okay, we got to go back and check 2. Okay, so 2 plus 2 is 4. 2 minus 4 is -2. Square root of 4 is 2. Is this true? Is this a true statement? Is 2 equal to -2? No. So this is what we call an extraneous solution. It's a solution that does not work. Okay, so we have to eliminate it. So my only acceptable answer is x equals 7. Okay. Does everyone understand how we do this? We get the radical by itself. Okay. So we get rid of whatever's being added or subtracted to the outside of the radical. Then we get rid of whatever is being multiplied to the outside of the radical. Then we square both sides once the radical is by itself. And we square it in order to get rid of the radical sign. Then we solve. And once we solve, we're still not done. We got to go back and check to see if the answers are actually valid. And if they're not valid, they're called extraneous solutions. So on the test, I might give you a problem and say, identify or solve the equation, in which case this is what you're going to do. Another question type I might ask you is identify the extraneous solutions. So I'm not looking for the answers that work. I would be looking for the answers that do not work. Okay. And in a problem, you may have all the solutions. You may have a situation like this where one is an extraneous solution, one is the correct solution. You may have a situation where both solutions are correct, and you may have a situation where neither solution is correct and that both are extraneous. Okay. Does everyone understand?
Yeah.
So let's have you guys try to do. Let's try number 9. Let's start off easy. Let's do number 9.
You want us to solve for S? Do you want us to solve for S?
Yes, for S. For number 9, I want you to solve for S.
Okay.
Is it okay if you can look at the problem and see what the answer is?
You can message me the answer. I'll tell you if it's correct or not.
All right.
Okay, so what do we do?
Simplify the radical
Is that
expression.
Okay, so let's do this. Okay, so first what do we have to do? We have to get the radical by itself. So what do we have to get rid of that's around the radical?
Move
1
to it.
1, right.
minus the 1 to the side.
Okay, now 5 minus 1 is 4. Now what do we do?
You square both.
Just simplify.
Okay, square both sides. When we square both sides, what do we get?
8s equals 16.
Okay, now we solve. So we divide by 8. And what is our potential solution?
S equal to.
Okay, now are we done?
Yep.
No. You have to go back and
Check
see
it.
if it's, yeah, you have to go back and see if it works. So 8 times 2 plus 1 equals 5. So 8 times 2 is 16, right? Square root of 16 is 4.
Four.
Okay. There's the solution. Any questions? So next time we're going to do more advanced problem types. Okay. And we're going to go from there. All right. And then I'll also start off by talking about quadratics tomorrow as well. So we're going to do more harder problem types involving this. And then the rest of this section, we're going to be talking about quadratics because that's the next thing you're going to be doing. Any questions? All right. So if there's no questions, I will see you guys tomorrow. All right. Guys, have a nice day.
See you, Mr. D.
Yeah.
Bro, dude, my second